Hello everyone and welcome back. Hopefully everyone got a chance to try and code out the solution we came up with in our last lesson. But if you didn't, that's perfectly fine. This is how I would do it. I've essentially moved over that test case that we had written and we're testing against, and I've just written the function that we remember for our area calculation that we came up with. Here I've just initialized the function. I'm calling it getMaxWaterContainer because that's what we're trying to do. And what gets passed in, which is this array, I'm just giving it the variable name of heights, because that's what they are. Each one is the height of a line. Now, inside, we need to keep track of that max area variable that we came up with. So here I'm just going to use the let to say that this is a variable that can change. The difference between const, which you've seen me used, is just that const can't change in JavaScript, whereas let means that this variable value can actually change. So that's just a little quirk in JavaScript if you're unused to it. So I'm going to say let max area, and I'm going to initialize this value at 0. Now, you remember that we needed two pointers, P1 and P2. So let's actually just do the same thing we did in our previous array question, which was the double for loop, because that is pretty much the same pattern of how these two pointers are moving throughout the array and giving us their respective values. So here I'm going to initialize my first for loop and say let P1 initialize at 0, while P1 is less than heights.length, then P1 increments. Now, before we move on to our second for loop, we need to think. Do we do anything with the value at P1 that doesn't need anything at P2? Do we need to initialize anything or create any variables? We don't. Our solution is purely based on P1 and P2 together, so we don't actually need to do anything inside of our first for loop. We can just immediately step into our second for loop. So here we want every single value to the left of P1. So I'm going to initialize P2 equal to P1 plus 1, the same way we did in our previous array question, and then everything else is the same. We want P2 to traverse up to the end of our heights array, and then P2 increments the same way. And now that we have P1 and P2, remember our actual area function. What we want is this calculation right here. We want to get the minimum value between A and B. So inside of your language, there's probably some shipped math min method by default. You have to figure out what yours is. In JavaScript is math.min. I'll show you how it works. So first what we want to do is we just want to initialize some value called height. And here I'm going to pass in math, which is just this object that ships in any JavaScript execution context. And on it are all these different methods that can do some kind of math-related functionality. So here it's math.min that I want. And what you can do to it is you can pass in any number of integers. So let's say I pass in 1, 2, 4, 7, 3. What this method gives me back is it just returns me the value that is the least. So here I just give me back the 1 right here. So that's all this math.min does. Every language has their own version of this, I'm pretty sure. You just have to find it. So here what we want to pass it is we want to pass the heights value at P1 as well as the heights value at P2. So that's what we're doing. This is the exact same as what we were doing here. Except instead of A and B, those values are at P1 and P2. That's the only difference. Once we have our height, we also need to calculate our width, which as we remember is just the index at B minus the index of A. So the index of P2 minus the index of P1, which is P2 and P1 respectively. So here we can say const width is equal to P2 minus P1. And that's all we need for height and width. Now what we need is we need the area. So here, if we remember, it's just the multiplication of those two values. So we can say const area is equal to height multiplied by width. Next, what we need to do is we just simply compare our existing max area against our newly calculated area. And remember, we want the maximum between these two values. So just as you might suspect, there was a min that we just used right here, that means that there must be a max, most likely as well in the math object. And in our case, there is. So it's very important that you do find that method. What we can now do is we can say that the max area is equal to math.max between the current max area and our newly calculated area. And then we just close our brackets. So let's close our second for loop, and then the for loop right after. And then we just return our max area. And now we also close our original function, and this is our solution. So it looks relatively similar to what we had in our previous array question, because the way that we were moving through this array is pretty much the same. So let's just now double check for any spelling mistakes, make sure that it's all working in case we have any typos. And to me, it all looks okay. This is a good chance for you to just double check your code and see if everything's okay. And now that we have a working solution, or what we believe to be a working solution, we have to run it against our test case. So here what I've done is move the code we just wrote into its own REPL file. We're going to test it against our test case that we've been writing here. And we see we get the right answer of 28. This is what we were expecting. What I want everyone to do, though, is make sure that every line of our function is doing what we came up with in our previous solution. So just make sure everything works. Also, test it against all those previous test cases we came up with, and make sure that this solution is a valid solution. So everybody take a crack at it using either this REPL code or your own handwritten code, and in the next lesson, I'll walk through it as well. But I just want everyone to take the challenge and do it themselves for practice. And I'll see you in the next lesson.